So as I kind of alluded to in the last video, we're going to continue our discussion of total, average, and marginal physical product with Excel. So all that I've done is I've just copied the exact same table that we were working with last time into Excel, and we're going to go ahead and start working with the average physical product, just recreating the average physical product and the marginal physical product of labor that we had in the last video. So if we remember, average physical product doesn't exist for the first column because you're dividing by 0 over here. But I'm going to go ahead and enter it here just so that you can see that we are dividing by 0 and kind of get a feel for what's going on. So average physical product is just total physical product, which is always in the cell just to the left of it, divided by the amount of labor that's being used, which is just going to be one more cell to the left. So I'm just going to go ahead and hit enter. And then I'm going to go ahead and drag that down, because in Excel if you click the bottom right corner and then just drag it down, that will go ahead and copy the formula into all of the cells below it. So this guy, 5 right here, is just 5 divided by 1, and 6 right here is C9 divided by B9, so that is 12, which is in C9, divided by 2, which is in B9. And then same thing for 8. And all of these others are divided by zeros right now, and we're going to ignore those because we haven't filled in the rest of this table yet. So then marginal physical product, if you remember, does not exist for the first row either, and so we'll go ahead and start this one on the second. And so marginal physical product is just going to be the change in total physical product, and the way that I'm going to represent that is this row right here minus this guy. So 5 minus 0 is going to be the change in total physical product divided by the change in labor, or the change in units of labor put into the production process. So divided by 1 minus 0, which will just be 1, of course. So there we get 5, and this reminds us of that rule that I was talking about last time, that for the first unit of an input, in this case labor, for the first unit of labor, the marginal physical product will equal the average physical product. So dragging this down, just to go ahead and extend that, we get these marginal physical product ones. And this 8 actually isn't valid, but we'll not worry about that for now because that'll change really quickly. Okay, so this is exactly where we were, just this table right here is exactly where we were last time. And so now I'm just going to go ahead and fill in some more numbers here, and we're going to go ahead and just kind of go from there and then kind of draw some more conclusions. So if labor is 6, let's say that total physical product, and just ignore what's going on the graph for now, it'll all work out when we're done, is, let's say that it jumps up to, I don't know, let's pick 50. No, let's do 60. And that's all that we need to put. And you'll see that our average physical product is 60 divided by 6, which is 10. And our marginal physical product is 14. And 14 is coming from 60 minus 32, which is going to be 28. So this right here, I'll just type because I can't write in Excel. So this is 60 minus 32, and that entire thing divided by 6 minus 4, which is 2. So just to make sure that I'm not confusing you, I'm getting the 60 from right here, the 32 from right here, and then 6 minus 4. So this is just the increase in total physical product divided by the amount of extra workers that we added. So I added 2 more workers, and I gained 28 more units of corn, 28 more bushels of corn. So that's where my marginal physical product is 14, because that's 28 divided by 2. So now I'm just going to go plug in some more numbers because I kind of want to get down to talking about some more kind of rules, I guess. So we're going to go 7, and we'll go 10. We'll go 70 here. So with 7 workers, we make 70 bushels of corn. And then we'll say with 8 workers, we make 75 bushels of corn. and then let's say with 9 workers we make 70 bushels of corn again. Alright, so that's all that I wanted to get into this table. Now I want to talk a little bit more about what's going on. And so most of this talking is going to go on with the graph, so I'll go ahead and make my way over to here, and we'll talk about this guy. So the first thing is that in the last video I said that if marginal physical product is greater than average physical product, then average physical product will be increasing. And we see that that's true here. When the blue line is above the purple line is going up. Now when the blue line is below the purple line is going down. So in English, that means that if marginal physical product is less than average physical product is decreasing. So I'll go ahead and type that over here. So if marginal physical product is greater than average physical product, and this is review, I said this last time, is greater than average physical product is increasing. And then another way of saying that is that, or not of saying the same thing, but of saying something different, is that if marginal physical product is less than average physical product is decreasing. So the way that I like to think about this is with GPAs. So if your semester GPA is like your marginal over here. So if your semester GPA is greater than your average GPA, then your average GPA goes up. And if your semester GPA, your marginal GPA, is worse than your average GPA, then your average GPA goes down after that semester is done. So think of marginal like your semester GPA and average like your average GPA. So the next thing that I want to say is that when marginal physical product I'm kind of jumbling up my ideas. So if what I want to say next is that total physical product, and I guess that I'll just keep on writing in this box. So total physical product must be greater than 0 because you can't make negative of something. And so if total physical product has to be greater than 0, so also does average. So total physical product must be greater than 0 and average physical product must be greater than 0. But marginal physical product definitely does not need to be. And we can see that because we have a -5 right here in this last entry for marginal physical product. So what this means is when I add the 9th worker, when I go from 8 workers to 9 workers, I produce less. I was making 75 bushels of corn, and by adding that 9th worker, now I'm only making 70. And so the rationale behind this is that the 9th worker is getting in the way. The 9th worker, there's just too many people on this farm, and he's just getting in the way and confusing everyone and just in general making the farm less efficient. So if marginal physical product is negative, total physical product will be decreasing because marginal physical product is the change in output that can be contributed to the last unit of that input. So we add 1 unit of labor and total physical product changes by -5. Total physical product decreases by 5. And that's exactly what we see right here. So total physical product and average physical product must be greater than 0, but marginal physical product can be positive or negative. And then finally, the last thing that I want to say is if marginal physical product is positive, total product is increasing. because we're still going up. We're still, even though we're adding a lot more units of labor in this case, of an input, our total product is still increasing. And then if marginal physical product is negative, total product is decreasing. And that's this last entry right here, going from 8 to 9. So what that's saying is we add one more unit of labor and we make less than we did before. So the very, very final thing is that total physical product reaches a maximum when marginal physical product equals 0. So that is as productive as this farm can be, is when marginal physical product is equal to 0. And we can see that that is somewhere in between 8 and 9 units, and the way that Excel graphs things, it just kind of puts them in one area or another. So this graph isn't going to line up perfectly, but we can see that right about here is where marginal physical product equals 0, and our maximum is just a little bit to the left of that, and that's just a function of how Excel graphs things. But in general, if Excel could graph these things perfectly and could kind of create values in between these values that I've given it, then it would be exactly where marginal physical product equals 0. So I hope that last bit didn't confuse you, but just kind of take it on faith or kind of work it through with some more fine numbers, some numbers closer together, and you'll see that total physical product is it reaches its maximum when marginal physical product is equal to 0. So that's all that I want to say with these. You do need to be able to kind of understand all of this logic in this box right here, and you need to know how to calculate them, how to work with them, how to get one from the other and go back and forth, and all that kind of good stuff. So I hope this was helpful. Let me know if there's anything else I can do, and I'll see you in the next video.